Hello everyone, today we're going to talk about intersections and complements. We're going to let a universal set, which is an entire collection of elements, and we're going to let that be U, and we're going to set that equal to a set 1 all the way through 20, 1 through 20. And then we're going to have two subsets, which we'll call A and B. Set A will have 1, 6, 8, 11, 14, 15, 16, 17, 18, 19, and 20. And subset B will contain the elements 1, 3, 5, 7, 8, 9, 11, 13, 18, and 19 in red. The problem is asking two things. First, list the elements in set A. List the elements in the set where we have an intersection of all the elements in set A but are not in B. And we're going to write that out. So what this really means is that this here is you're going to find this set of all the elements in A and not in B. And same goes here. List the elements in the set where you have all the elements in B that intersect with all the elements that are not in set A. So we just clearly write that as all the elements, okay, in set B and not in A. It's really important to establish what that means so that you can solve the problem. The next thing I want to show you is a diagram, the Venn diagram, that we're going to use to organize these elements and what set they belong to. And we can determine, the first thing that we should determine is the intersection. So if you remember, as a little review, that if you have the symbol if you have the upside down U, that's going to be and, okay, and that's the intersection. If you have a regular U, that's going to be or. That means you're going to have elements in one set or another. Intersection means we have elements that are in both sets, which means they'll be common or that they will exist in both sets. So what we're going to do is we're going to draw a nice little diagram. Okay. And we're going to call that our universal set. So everything in this box is our universal set. And then we're going to have two subsets. We'll just call this one subset A, subset B. All right, so let's go to set A and let's look at where the elements exist in both sets. Okay, if you see that 1 is going to exist in both sets, right? 1's in set A, 1's in set B. 2, 3, 4, 5, 6, how about 8? 8 exists in both sets, right? Look at 11 exists in both sets. Whoops. Okay. 12, 13, 14, 15. How about 18? And how about 19? So all the numbers that I circled exist in both sets. Clearly see that, right? So that means that all the numbers that exist in both sets should be listed here. You have 1 and you have 8, and you have 11, and you have 18, and 19. And the next thing that you want to do is write down all the elements that are in A but are not in B. And we do that by just looking at set A. Look at all the numbers that I did not circle, okay? I did not circle 6. 6 should be in this set A. 14, 15, 16, 17, and 20. Those numbers are clearly in set A only. And if you look at the numbers that I did not circle in set B, well, 3, 5, 7, 9, and 13 are not are in set B, rather. These are the elements that are in set B but are not in A. So it's always important to fill in your Venn diagram so you know what elements go where. Now, there's one more thing I would like to do. We need to find the elements that are not in A and B. So go back to the original two subsets that I gave you, A and B. You notice that number 2 is not found in set A, okay? And it's also not in set B. So it's number 2 is not in either set, okay? It's not in either set. 4 is also into that category. It does not exist in set A as well as B. You don't see 4 anywhere in set A, and you do not see 4 anywhere in set B. And I could say the same if you look at it. 5 exists, 6 exists in set A, 7 exists in set B, 8 exists in both A and B, 9 exists in B. But you look at 10, you don't see 10, right? Anywhere in set A as well as B, so you got to include 10. And 11 exists in set A and B, but 12 does not exist anywhere. So you should put those in the universal set. Now that we have all our numbers organized and placed in its proper location in the Venn diagram, we can actually go ahead and solve the, more like answer the question that's being asked here. And that is, what is the intersection of the elements that are in A but are not in B? And that's the question, right? That's what this original question is here. It says list the elements in the set where they're in set A but not in set B. And the upside down U indicates an intersection. Okay, so we're going to do that right now. So what we want to do is go back to where it says, okay, what does this first problem says? It says list the elements in the set where we have all the elements in A but are not in B. Well, let's do that. Let's look at the Venn diagram we did here at the bottom. You notice all the numbers that are in red, 1, 8, 11, 18, and 19, that's the intersection. That means those elements will be in both A and B. However, if we read the problem very carefully, right, all the elements in A are basically all the ones that I've listed right here, 1, 6, 8, 11, 14, 15, 16, 17, 18, 19, and 20. Okay? And I want all of those elements in A, but I do not want the ones in B. And the ones that are not in B are going to be basically 1, 8, 11, 18, and 19. It's basically the numbers that I circled in blue here. okay? So all the numbers that we want in A but are not in B will be this. Okay, you can just literally identify those. So we're going to write those here. We're going to have the elements 6, 14, 15, 16, 17, and 20. Okay, can you see that the elements in green that I wrote are in A but are not in B? And then we could do the same for the second problem. What are the elements in B but are not in A? If you look at the diagram, you can see that these elements right here are in B but are not in A. So we're going to write those as 3, 5, 7, 9, and 13. Can you see that? This is why it's so helpful to draw the Venn diagram. You know, it takes a few extra minutes, but you will have a very schematic view of what's going on. You have everything organized, you have your universal set, you have your subsets A and B that are part of the universal set, you have the intersection, which means you have all the elements that exist in both subsets A and B, which are 1, 8, 11, 18, and 19 in red here in the middle. And then you can begin to answer the question, break it down. All right? So that is the next thing that you have to do, okay? The final thing that we should do is, we still haven't answered the question because we want to find the intersection of all the elements in A that are not in set B. And that's what we're going to do now. What I have done so far is give you the layout, the plan, if you will, is how to break this down sequentially, one step at a time, prepping the problem, and then now we have everything in front of us, and then we can just sort of lay it out and just answer the question. Okay, so we're going to do that right now. So the problem is stating that we have this, you know, you have all the elements in A that intersect all the elements that are not in B. Well, we got to consider the universal set here when we do this. Remember, the universal set contains 1 through 20, and then don't forget we organized these numbers, these elements, that 2, 4, 10, and 12 were not in either set A and B, so we had to put them in the universal set. That's why they're separate from A and B. All right, so basically if you look at this, and I'm going to just use my red here, all the elements in A, okay, that all the elements in A would be 6, 14, 15, 16, 17, and 20, okay? In addition to that, we need to include the elements in the universal set 2, 4, 10, and 12, okay? So let's identify all the elements in set A, and that's this right here, okay? 6, 14, 15, 16, 17, and 20. That's the first part of the problem. Okay, and then now, if you want to find all the elements in A that are not in B, we need to include the elements in the universal set as well. Okay, now we want to find the intersection of those. We want to find the intersection of all the elements in A, okay, as well as all the elements that are not in B. Well, the intersection is going to be right here. Let me use this in blue. This is the intersection. He said this is the intersection of all the elements okay, that are in A but not in B. That's what it would look like. You would just shade in all the elements in A, okay? And we have it right here in green: 6, 14, 15, 16, 17, and 20. And vice versa is going to happen when you do the second problem, okay? If you list all of the elements in B that are not in A, then you're going to have this, okay? You're going to have all these elements right here, okay? But if you're including all those elements, you need to include the ones that, you need to include the elements in the universal set as well, okay? So all the elements that are in A but are not in B, okay, you have to include the universal set as well, all right? But when you do the intersection, it's basically going to be all of these elements right here. All right, and we listed them already in here: 3, 5, 7, 9, and 13. That's the intersection. Okay, so my advice is to lay out the Venn diagram, because it'll give you a more direct path of where things are, and you can kind of circle them and say, okay, these numbers are here and these elements are here. Do it step by step as I showed you, and that should help you, should guide you along in how to do these problems. But it's really important to understand what a complement is. Also keep in mind that a complement, for example, let's look at the first one, complement B complement rather, is written like that, but it's also written as B prime, and it's also written as bar over it, okay? So all of those have the same exact meaning. It just means the complement, which means elements that are not in B. So be aware that different notation can be used in various texts, in lectures and other professors, but just realize that all three of those mathematical symbols mean all the elements not in B. Okay? Thank you so much for watching. I hope that this clarifies complements for you.